I'm Peter Haddock and I'm here at the Malaga Learning and Demonstration area, and we're in the engine department with Allen Chen. Alan, we have the C13D engine behind us. This is a major breakthrough that was originally launched at ConExpo 2023. Now we've gone through testing and everything. It's 2 years later. Tell us all about what's been happening and the engine itself.
Sure. So at a high level, the C13D has been in the hands of a few very select, very special customers. They've accumulated more than 2,000 hours on it. They've provided their feedback. Things like it's quieter, it's better fuel consumption, you can feel the power, you can feel the responsiveness, a lot of really good information coming from them. And they've also given us opportunities to improve upon the product a little bit.
Talking of improvements, Alan, you were saying to me earlier that it's not just about diesel, it's also about alternative fuels, drop-in fuels like hydrogen, but others as well, isn't it?
Absolutely. So the C13D, of course, is capable of up to 100% HVO fuel. Yeah. And with the after-treatment system here shown, it's capable of up to B20, standard biodiesel, up to B35 where necessary in places like Indonesia, for example. And if you don't have the after-treatment system, you can actually go all the way up to B100 in terms of its biofuel. Now, the cool thing is, this engine is also the cornerstone and the foundational piece of some of our hydrogen work. Wow. And as seen in some of our other press releases on the Project Thor, we're looking at making up for some of the power losses you might experience when you do use hydrogen by adding a motor generator unit to the back. Yep. Maybe coupling it up with a battery, some alternators, so that now you have an advanced power unit that would be able to perform like a diesel unit, even though you're using hydrogen. Our customers would historically, and they will continue to mount their pumps, like steering pumps, hydraulic pumps on this, because the engine is so much more than just powering off the flywheel. It's also powering other parts of their machine to make the machine work.
Power density, but yet in a smaller footprint. How was that made possible?
Yes, so at the heart of it, right? Yeah. To make power, you need fuel and air. Yep. And if you want more power, you need more fuel and more air. Yep. So one of the biggest recipe building blocks on this engine is that we now have a common rail fuel system. Okay. The common rail fuel system is capable of injecting a lot higher pressure fuel faster and in more volume. It's all happening electronically and it's all being controlled by the ECM.
And the ECM has got loads of sensors in here that knows exactly what's going on, and it's that level of sophistication and accuracy, isn't it, that optimizes the performance?
Absolutely. The magic actually happens inside. If you can think with me, like the software behind it is what really makes all of this work. Yeah.
So the big question, the big question is, when can people get this engine into their equipment?
Yes, so like I mentioned, customers have been running this, and we've, of course, have been accumulating tens of thousands of hours in our lab, pushing it to its limits. I am glad to say that we will be opening up order boards so we can begin ordering these engines as soon as the end of this year, leading into, of course, next year's production dates.
So that's 2026, people, that you'll be able to see this engine out in the field. Great to see you again, Alan. Thanks very much.
Thanks, Peter.
But Alan, wait. If you want to actually see the difference between this and the previous one, follow me over here.
If you compare it to the C13D, some of the components that I talked about, removing so that it becomes a module, these are examples, right? You have your water pump, you got an oil pump there, you got an oil cooler, you got an oil filter. All of these pipings, these jumpers, these tubes, this thermostat housing that's up here, all of that on the C13D has become one component.